Okay, so we are attempting to develop formulas for more complicated trig expressions now. More specifically, we're going to look at addition and subtraction. But in order to do that, we have to understand the impetus. Why do we care about these formulas? Why do they matter for us in our solving process? So what we'll start with is a couple of examples that will show us why we actually need to have more formulas than what we have right now. And they start slightly differently than the examples we've done in class, in that these examples are solving an inverse trigonometric function. So we actually start with the inverse trigonometric function on the page, and then we solve down in the same way to get to x. But in this case, right, if we look at our first inverse trigonometric function, we should recognize that x is a side ratio here. Okay, x does not stand for an angle, rather x stands for a side ratio. But our process remains the same here. We just simply want to take the tangent of both sides. So I'm going to apply tangent to both sides of my equation. And on the left, we reduce to x. And on the right, I just simply need to know what the tangent of minus 3 pi over 4 is. That's an angle in the third quadrant. So I know that the side ratio is going to be 1, and that's going to be positive because it's in the third quadrant. So I get a nice easy answer of x equals 1. Very straightforward, very simple. It's not difficult to solve basic inverse trigonometric functions. It's actually almost easier than our regular trigonometric functions. It grows more complicated, however, when we move down a problem, and that's when we look at arc sine x plus arc cosine x equals pi over 3. And we need to say to ourselves, well, now what do I do? Right? Now how do I reduce those expressions? And our general process remains the same. We want to try and apply an operation to both sides of the equation that reduces our expression down. So I'm going to take the sine of the entire expression. I'm going to take the entire left-hand side and make it the input on a sine function. And the right-hand side reduces down to root 3 over 2. And on the left-hand side, I'm left with a question of what do I do now with the expression that I have? We do know a couple things. We know that sine of arc sine of x equals x. And we can figure out what sine of arc cosine of x is simply by building a triangle around the angle arc cosine x. So if we build a quick right triangle, we say, okay, let's let this angle be arc cosine x. Then we know, because of what we know about the way that our inverse trigonometric functions are built, that that angle, okay, it's the angle that has a cosine ratio of x, meaning that its adjacent side has to be x and its hypotenuse has to be 1, and the third side in that triangle, therefore, must be the square root of 1 minus x squared, given what we know about the Pythagorean theorem. If I then want to know what sine of that angle is, I simply take the sides of my triangle and say that sine of arc cosine of x is going to be equal to the square root of 1 minus x squared. It's going to be the adjacent side over the hypotenuse. However, the question is, right, when I get sine of arc sine x plus arc cosine x, is it as simple as taking the sine and distributing it to both terms? It is certainly what we'd like to do. Right? It's certainly what we'd like to do in this case, but maybe it's not necessarily true. Let's check an example to see. Let's just assume that I'm going to take sine of pi over 4 plus pi over 2, and we'll see if our distribution works. On the right-hand side, we know that should be the same as sine of 3 pi over 4. Well, that's going to be sine, if our distribution works, sine pi over 4 plus sine pi over 2 should be equal to minus square root of 2 over 2. We look on the left-hand side, I've got square root of 2 over 2 plus 1 equals minus square root 2 over 2. That doesn't work. Right? So the distribution is not valid. It's not going to be able to give us the answer that we're looking for. And that is really the impetus for needing to decide what happens when I take the sine of one angle plus another angle, or the cosine of one angle plus another angle. And that will become the first question that we need to answer, and then we'll use that information to be able to do more as we go along.